Hello everyone. In this video I'm going to do some questions related to length and distance of vectors. Let's see what the question asks. Two vectors are given, u and v, and question has three parts. Part A asks find the length of u. Part B asks find length of 3u minus v. And part C asks what is the distance between u and v. So what we need to know to be able to solve questions like this is just a formula. What is formula for length of a vector in Rm in general? So if I have a vector u with m components, this m can be 3, 4. In this specific example, it's going to be 4. Then the length of u, which is this is how we denote it, is equal square each component. So I square first component, second component, and mth component, and add all these numbers. You're not done. You have to find square root of that number. So square of components, add them, find the square root. And yeah, basically what is inside length notation, you have to find a vector out of it and then use this formula. But what is distance between two vectors? So this is how we denote distance between two vectors. Again, it doesn't matter if we're in R2, R3, R5, Rm. In general, you have to find first u minus v or v minus u, doesn't matter. Then you get a vector and then find the length of that vector. Okay, so now that we have formulas, let's go ahead and solve part A. So here question asks what is the length of the vector u. So I have to do each component is squared. So 4 squared plus 2 squared plus negative 2 squared and plus 1 squared. Add them and find square root of that number. So in this case we have 4 squared is 16, 2 squared is 4, negative 2 squared is again 4, and 1 squared is 1. And if I add 16 plus 4 is 20, 20 plus 4 is 24, plus 1 is 25. And we know that the square root of 25 is 5. So that's part A. And as I said before, the only thing you need to know is the formula for the length. Okay, what about part B? Part B asks about what is the length of this vector 3u minus v. Okay, let me write this a bit higher because I need the space. B is find length of 3u minus v. First, I have to find what is this vector inside the length notation. So I have to do scalar multiplication 3 times u. Scalar multiplication means that you multiply the number, the scalar, 3 to the components of u, the vector. So 3 times 4, 3 times 2, 3 times negative 2, and 3 times 1. I have a vector and then minus v, which is 2, 4, 0, 1. Okay, let's see what is this vector. You have to know that subtraction or the difference of two vectors you can find by just subtracting component-wise. So the first component is 3 times 4, which is 12, minus first component of the second one, which is 2. 3 times 2 is 6 minus 4. 3 times negative 2, which is negative 6 minus 0. And 3 times 1 minus 1 is 3 minus 1. Well, we are very close now. I have the vector, which is 10, 2, negative 6, and 2. I have a vector. All the components are there. And I can use this formula to find the lengths. So what I need to do is find square root of first component squared, second component squared, third component squared, and last component squared. Let me continue here. So 10 squared is 100 plus 2 squared is 4, negative 6 squared is 36 plus 2 squared is another 4. And what I have here is 100 plus 4 plus 36 is 140 plus 4, 144. And what is the square root of 144? You better to know this. It's 12. So 12 squared is 144. So the length of this guy, I first found what is the vector, and then squared each component, add them, find the square root, and it was 12. Okay, so that was part B. What about part C? Part C, as I mentioned before, let me keep this in a box. As I mentioned before, the distance of two vectors is nothing but length of difference. So u minus v, or v minus u, find the vector, and then find the length of that vector. In this case, I need to find u minus v, meaning that you do subtract component-wise. 4 minus 2, that's the first component. 2 minus 4, that's the second component. Negative 2 minus 0, and 1 minus 1. Okay. Okay. Then I have the components are ready. It's 4 minus 2 is 2. 2 minus 4 is negative 2. Negative 2 minus 0 is negative 2. And 1 minus 1 is 0. And then, yes, I can now find the length, because I have each component. The first component squared, second component squared, third component squared, last component squared. And I have 4 plus 4 plus 4 plus 0, this is square root of 12. And you can simplify more and write 2 times root 3. Okay, so these were the different parts of the question, but again, to very quick wrap up is that if a vector is given with any number of components, the length of that vector is square each component, add them, you get a number, find the square root of that number. That will give you the length of that vector. And what is the distance of two vectors? You first subtract those two vectors, you get a vector, and then find its length. Okay,